Good morning, everyone, and welcome to reInvent. It's going to be a fun and exciting week. So I'm Reef D'Souza. I work with AWS Professional Services, and joining me is Rajiv Sharma, a Senior Application Security Architect at Vanguard. And today we'll walk you through the challenge of striking balance between agility, governance, and security in your IAM design, especially when it comes into the context of enterprise scale. So over this session, first I'll briefly talk about some key enterprise security objectives, and then talk through a quick overview of what AWS provides in terms of building blocks, which can be along the lines of AWS accounts, IAM users, groups, roles, and policies. Put all these together in an enterprise scenario, keeping federation in mind, and then hand it over to Rajiv, who will walk you through Vanguard's journey to the cloud and how they design for IAM to meet these security objectives. So the security objectives, the key requirements we see with most engagements with our enterprise customers, first is defense in depth. This is to ensure that our customers take a risk-based approach to implementing security controls, closely aligning with clear directives and policy. These controls can span from the technical side of things. It can be preventive, detective, and responsive controls, and should be implemented to sufficiently reduce the risk of any breach, or in the worst case, ensure that there is some kind of real-time feedback, alerting, monitoring, and even automated response. Next up is separation of duties. And as we see enterprises move into this world of infrastructure as code, you start to see the lines start to blur between different job functions and capabilities. For example, a sysadmin is not just a sysadmin. You have to have an idea of looking at your infrastructure as a software artifact. Similarly, developers need to have some understanding of what infrastructure as code means, being able to configure the infrastructure components. And so when you have an enterprise with multiple business units, hundreds and thousands of applications across these business units, getting this can be pretty challenging. And then finally, the principle of least privilege. So humans and data, they do not mix. The goal is to get the humans away from the data, especially when it comes to production environments. But then with AWS's pace of innovation, and you have these new services, features, and functions coming out, everyone wants to get their hands on the shiny new object. And so striking the balance between innovation, that's the whole goal of moving to the cloud. Striking that balance, as well as putting these governance guardrails in place to implement least privilege, can also be another big challenge. So now that we've seen these security objectives, I'll talk you through the key building blocks. First up, I'll talk about AWS accounts and the merits of using these accounts as a means for isolation. So first up, look at accounts as a security boundary. So you're trying to determine, prevent things from coming in, basically, when you look at it as a security boundary. So an account isolates user and data within the confines of that account, subject to the security policies for that account. So you're reducing the blast radius with this isolation, and thereby, again, reducing the impact of a critical event like a security-related event. Next up, we have resource containment. So the other main requirement we get is, now that we've prevented things from coming in, or we can address that challenge, how do we prevent things from going out? So look at accounts, AWS accounts for resource containment. All these resources are contained within that account and are limited to that specific account. For example, you cannot just launch an EC2 instance in one account and then drag and drop it into another. And one common use case is for highly sensitive workloads, or those workloads subject to, say, PCI or HIPAA or other regulations. You can isolate those workloads within one account. And then finally, accounts provide you this natural boundary for administrative control and visibility, where independent administrative groups can get varying degrees of administrative privileges to the resources within these accounts. These can be based on workloads, based on data sensitivity, business units, and as well as where you are in the development lifecycle. So a developer might have read-write access to a a development account, but it can only be limited to read-only access in a production account to specific logs and metric monitoring tools. Now that we've seen accounts, let's look at the core components that AWS Identity and Access Management provides. So IAM is a web service that helps you control and define who can actually access your AWS resources, as well as how they can access it. So we're covering authentication and authorization here. So first up, we have IAM users. Users can be an individual, a system, an application that requires access to your AWS services. And a user account would consist of a unique name and a form of credentials such as passwords or access keys. Passwords typically are needed for access to the AWS Management Console. And when you have a lot of users, the next step is you want to logically group them together based on specific classifications, based on the privilege levels they require. So IAM groups provide you with this logical construct that gives you this operational efficiency, where you have bulk permission management when you have users of different requirements for privileges in groups, as well as for users moving from one team to the next. It provides you portability. So you have scalability and portability provided by these IAM groups. Next up, we have roles. Roles are IAM entities used to delegate access to your users, applications, and other AWS services. These are intended to be assumed by trusted entities. So think of roles like a hat, which has a list of permissions attached to it. And the wearer of that hat will then get those permissions to perform certain actions on other AWS services. IAM roles do not have credentials such as passwords attached to them, and they are provisioned with short-term credentials which are automatically rotated, thereby helping you, again, design for security. They also enable you to have a many-to-one mapping. Say, for example, you have a list of database architects who need to work with Amazon RDS. So you create a role with the permissions that these database architects need to perform in terms of actions with Amazon RDS. And all these admins would then assume this role and thereby get those permissions. And then when we're talking about permissions, finally, we have IAM policies. So policies are simple JSON documents within which you define these permissions, define what actions the entity that these policies are attached to can or cannot do. So these policies can be attached to one of the previous entities, the users, groups, or roles. So let's get back to the basics. InfoSec 101, when we talked about access control, way back when we started our journey. So first up, we have a subject. We have an object, and the subject wants to perform certain actions on that object. And then you want to specify certain conditions that, all right, this subject wants to perform, say, like write to an S3 bucket under certain conditions that this subject has come from one of the IP ranges from my data center, and maybe between Monday to Friday. So when you're designing IAM policies, remember this model we call the PARC model, where you have the subject, which is a principal. You have the actions the subject can perform on a specific resource, which is the object, under certain conditions. And another important element to remember when designing IAM policies is the effect. That is whether you want to allow the subject, or the principal in this case, allow or deny the actions that you're listing out in that policy. So putting it together when it comes to roles and policies, how it's used to implement least privilege and separation of duties. Again, we just go back to the user who wants to perform certain actions on objects in this Amazon S3 bucket. So first up, you would construct a policy within a JSON document, attach that policy to a role, and so when this user assumes that role, they can then perform these actions on that object. Now that we've seen how roles and policies can be used to implement least privilege and can be constructed using the PARC model, we talk about the enterprise scenario and the need for federation for AWS. I typically break down this conversation into three main pillars. First up, we have users. If you're going to create a lot of IAM users, you also have users with credentials, such as passwords or access keys. And this would create credential sprawl. That is one goal of the security team, is to reduce that attack vector, you could say. And so with federation, you bring AWS within the fold of your single sign-on. Next up, we talk about the security team and the challenge they have with long-lived keys. So outside of username and passwords, you have access keys. These are keys that developers are accustomed to using and often find funny ways to get embedded in code. And this keeps the security team up at night. So with federation, using short-term tokens, you reduce the risk of a breach caused by leaked keys. And then finally, we have our compliance team. The compliance team has spent many years building mature processes for reporting compliance with best practices. And without federation, AWS becomes this one-off entity. They have to build out these processes again, prove their onboarding and offboarding processes when it comes to users joining teams, leaving teams, or leaving the organization itself. And so again, when you bring federation into the mix, you bring AWS under this umbrella of your already existing mature processes. So now let's put all of this together in an enterprise scenario. We have multiple lines of business or business units. And for each of these business units, you'll have hundreds of thousands of applications. So for this app development lifecycle, you'd provision multiple accounts for each of these business units, each of those applications, as per requirements for isolation that we mentioned earlier. These can be accounts like dev, test, staging, production, maybe PCI or HIPAA accounts. And for those, you have for each business unit, you have multiple teams there. You have developers, you have system admins, you have security, you have business users. And for those users, you construct a lot of different roles with varying levels of permissions defined in your IAM policies, for which, for example, in a development account, there might be more privileges versus in a production account or even in a compliance required account, such as PCI, there would be more restrictions on what data can be accessed. And then, of course, keep in mind the nature of the workload going into these, that is being deployed on these accounts, subject to multiple regulatory bodies or strict governance requirements. So altogether, at scale, you have lots of AWS accounts, lots of users cast into a lot of IAM roles, and there are multiple access vectors, such as need for access to the AWS Management Console, API or CLI access. For these, you have to design fine-grained resource permissions and how it all needs to be traceable. And then in the worst case that your identity provider is not available, you will have provisioned break class IAM users who have a higher set of privileges, and to make sure your governance and other security requirements apply to those highly privileged users. So this is a challenge at scale. And so to talk through more of how this challenge was addressed, I hand it over to Rajiv, who'll talk about Vanguard's journey to AWS.
Good morning. Hi, my name is Rajiv Sharma. I am a security architect at Vanguard. I've been at Vanguard actually for 18 years, and the majority of that time has been working in the security field in one of the organizations at Vanguard. So I'm going to tell you a little bit about how we took the ideas that Reef had presented here and implemented them at Vanguard. First, what is Vanguard? We're actually one of the world's largest investment companies, offering a large selection of low-cost mutual funds, ETF, advice, and related services. The core purpose is really take a stand for our investors. Our oldest fund has been around since 1929, and we've been in business since 1975 in Valley Forge, Pennsylvania. We are international, so we have roughly 180 funds on the US side and 190 outside the US. Okay. As far as some of the workloads that we're putting up at Vanguard, we're looking at things like web applications. So these could be EC2 instances that are serving up websites or REST services. Also doing things like EMR, so some of the big data analytics workloads are going up. And then also third are some of our third-party products, like our Windows-based applications, trying to move them off of physical hardware into the cloud. So that's really our first start into Amazon. So that's a little bit of background. Now, as far as governance, so we do have a lot of governance requirements, and they stem from authoritative sources. So this is where we get our control statements from. The first one would be the CIS, the Center for Internet Security, Amazon Web Services Foundations. So the CIS benchmark is really for how you would secure a data center. And Amazon has partnered with the Center for Internet Security to come up with a set of requirements for Amazon. So we look at those as a guideline. We also look at a very good document, the NIST 853, which also provides a lot of good guidance on how to secure your systems. There's also the SOC 2. So these are controls for service organization. We use SOC 2 as part of our audit procedures. And then since we are international, there is the GS007, which is out of Australia. That's their auditing and insurance standard boards. Above and beyond these standards, we have our own internal information security policies. So these would be things like HR policies that we put on. Some of the businesses, the lines of business, also have their governance requirements that they would like to put on above and beyond what's listed here as these authoritative sources. So taking these authoritative sources, we want to, since these are generic, we want to boil these down into some of our requirements, or what we call control procedures. So at a very high level, from an IAM standpoint, we want to make sure that there's a workflow in place that allows access to be automatically provisioned to an end user. So this could either be through a request flow, somebody requests access to a particular system, then all their access that they need for that system is granted automatically. Or it's done through an HR process. In other words, you were to join a division or leave a division, your access is adjusted accordingly automatically. Another requirement that we want to put out there is for credential management. So password and login parameters are configured in accordance with our corporate policies and procedures. So we're talking about password complexity, password length. Also, the number of times that you can use a password, the number of times you can attempt to log in and then get locked out. And then around the governance aspect, we want to make sure that user access is reconciled. So we have a book of record that says a certain user has these entitlements. Now we want to make sure in all the other systems, let's say our databases or our workflow tools or window shares or anything like that, and even in Amazon, that those endpoints reflect what's in our book of record. And then this user access is going to get reviewed by management semi-annually. So each one of the people managers goes through their employees and looks through to make sure that the access that they have, according to the book of record, is what they really should have in order to do their job. So as we started our journey into the cloud and we started taking a look at building some accounts, we started with basically we're creating IAM users in the account. And of course, when you have a multi-account strategy, you're going to have lots of IAM users that are created out there. Each one of these users will require MFA, so they're going to walk around with a bag of MFAs on their belt. They also have long-lived access keys, which is, as Reef had pointed out, a bad practice. These can cause data breach if they're lost or misused. And then, of course, you have the password stickies all over the laptops and the computers, right? So all of a sudden, passwords are all over the place, password policies are not followed, and the user is very confused. All right? Now, to pause here, I'll put a couple slides in here for what I call audit time. This is sort of like a mental checklist of where we are. So right now, we really don't know who that real person is, who that end user is in Amazon. There's just an IAM user out there. We can't tie it back to an actual human. There's no enforcements of usernames, and this is also causes that problem. The password policies are not consistent across the various accounts. The roles are not scoped into the account. In fact, there are no roles here when you have just IAM users. We have these long-lived access keys, which is the potential security vulnerability. There's also no well-defined request process. Hey, if Bob needs access to an Amazon account, who does he call? The account owner? Does he run his own credit card, create another account? We don't know. Again, we don't have any roles, so we don't know if anything if the policies are attached correctly, and none of the roles matching the job titles. Does Bob really need access to the things that he's asking for? So immediately we realized that this was going to be an issue, and we moved towards role-based access control. And this is really granting user access through IAM roles as opposed to IAM users. But as far as the workflow, a little bit of administration. So I talked about our book of record. So internally, we have a process where if a user, let's say Bob, submits a request for access, there's a role request. You can maybe think of it as a ticket or some kind of workflow system that's sent over to a role owner. This is a different person. This person is supposed to know what the role grants access to and who should have access to that role. There's also a piece of justification in there, like why is Bob asking for this role? Someone needs to justify this. If the role owner approves it, it gets updated in our corporate LDAP. So Bob's user identity gets mapped up to a role inside the LDAP structures. In parallel, all this activity is, of course, archived and logged. So every request comes in, gets archived, and here an auditor can actually take a look at what was requested and what actually exists at the endpoint to make sure that everything is reconciled. So that was the sort of our on-premise. Moving into Amazon, how does this work actually in practice at runtime during enforcement? So we have our user Bob, who's going to talk to, in the middle here, an IDP service. This is your identity provider. This could be any kind of SAML provider, or if you build your own STS token vending machine, things like that. Bob will go ahead and authenticate with this IDP to our corporate LDAP, and then make an assume role call. And what happens here, the IDP service knows what access Bob should have and can map them over to the correct Amazon SSO endpoint and the correct role that they need access to. Okay. Then Bob assumes this role. He now wears this new hat and can go ahead and do his job. Now, what are some of the benefits here? Okay, the secure tokens, the STS tokens, now have a time value on them. They're good for 1 hour at most. They can be configured up to an hour. There's also policies that are attached, and the policies show which Amazon services that Bob is actually allowed to use. All right, so why federate to IAM roles? This is just a little bit of recap. We're going to significantly reduce the risk of exposed access keys. We're going to take advantage of the corporate policies and tools. This would be things like monitoring. So we want to be able to monitor cloud usage. There's also the centralized credential management. So we now have the actual password policy enforced everywhere. It also applies, as I said, to lockouts. So once they're locked out in the corporate LDAP, they're locked out of all the accounts. And then I mentioned the joiner leaver movers. So through an HR system, you can update the corporate LDAP. Okay. So just building upon that, you're talking about the monitoring. Up in the corner, you see AWS CloudTrail. So every action, anything that you do, any API call you make, whether it's from the console or from the API CLIs or SDKs, gets logged in the CloudTrail. And we can monitor that. So now we know, if you take a look inside CloudTrail when you do federation, you'll see that there's a user identity in there. It's a combination of the role that was mapped, the actual Amazon role, and then we've also added their user identity to it so that we know exactly who's doing what in the accounts. The managed credentials and the authentication schemes, So we can provide strong authentication against our corporate LDAP, whether it's through user ID passwords, certificates, MFAs, or smart cards, or anything else that comes down the line, as long as our IDP service supports that. We also have an IAM team that can maintain these things. The IAM team can also go in and update maybe your password, maybe you locked out your password, call up the IAM team, say, hey, I'm Bob, here's a piece of identification, can you unlock my ID? And then I mentioned our HR systems. So this is part of the joiner labor movers, where if a new employee joins Vanguard, they're put into the HR system, and then there's a process to put them into the right roles into the LDAP and create their user identity. This also works in the reverse. When an employee is terminated, we can take away their access immediately from all Amazon accounts. Okay. So we started out with our roles. We started out with originally 6 roles. These roles were meant to enforce some segregation of duty and some responsibility to the end users. So we had, let's say, a deployment role. This was a role that allowed access to our production environments. And hello, I guess, got it, all right. This allowed access to our production environments and allowed for deployment personnel to actually take CloudFormation or stacks and deploy them into production. We then had our engineer role. These engineers, these are people who can create CloudFormations or actually experiment in the console and do work like standing up EC2s or Beanstalk or S3s, things like that. Our fraud team was there to take snapshots of different EC2 instances in case of a fraud investigation. We had our networking team, so we separated our network team from our engineers. We wanted to make sure that things like internet gateways or VPN gateways and things like that, route tables, were done by a separate group. We didn't want an Amazon account to all of a sudden connect to some foreign Amazon account or some foreign network. We had our operations folks. These are our 24/7 operations. So when something goes bump in the night, these are the people that get called, and they have access in production to fix things. They're not there to build out any infrastructure. They're just there to get it back up and running. And then we had our security team, like our IAM team. They would have the ability to stand up federation or do any of those types of things. Okay. So we talked about roles, but we also have IAM users. So there is a use case for IAM users. This would be for your break glass events. So let's say your IDP went down. How are you going to get into your account? You still needed some IAM users to actually break the glass and get into the account and stand federation back up. We also had our bootstrap users. So this is when a new account is formed, the birth of a new account. There is no federation at that point. You're standing it up for the first time. So these are bootstrap users that get created and then destroyed after the account is stood up. Their identities and credentials are stored in a vault. There's actually requires 2 people to get access to these credentials in order to do anything in any of the accounts. So it requires access from the IAM team and our security operations team. Okay, now a little mental audit again. Where are we? So now we know who that real person is. We had the HR system come in and populate our corporate LDAP. We have enforcements of the usernames, which is really good when we're doing monitoring. So we can see this username can tie back to an actual human. We have consistent password policies. We have all our password policies are in one place within the corporate LDAP, and then we've eliminated our long-lived access keys. Okay? So we're still not ready yet to put our workloads in the clouds. There's still a couple other things that we need to do here. Okay? Our multi-account strategy. So this is really the ability to reduce our blast radius. So when we started our journey, moving past our original few pieces of infrastructure, we had multiple accounts. So we had a production account and a non-production account, which we called our QA account. And these were created by our organization. You can do it either way. At the time, we had some production accounts and non-production accounts. You can push them back into the organization account. Then we needed a place for infrastructure engineers to do their development work. And we created a sandbox account. And this allowed them a little bit more access in a little bit smaller blast radius where they could go ahead and experiment with different technologies or even new services that we wanted to take a look at. Now, of course, all this is going to get logged into CloudTrail, and we didn't want anyone to go in and manipulate the logs inside CloudTrail. So we created yet another account called our audit account. This is where all our logs go to. All the CloudTrail logs are sent to S3 buckets in this audit account, where very few people have access. This ensures that our logs are not tampered with. Then we had those 6 roles. We had our, our engineer, deployment, fraud, security, operations. And we took those roles and added them to all the different accounts. So we took those 6 roles, put them across 5 accounts, and then, of course, we had 30 roles also created. And it was delineated by the environment, really, what sys level you're in, whether you're in a non-prod or a prod environment. Okay. Then we had a requirement from the different lines of businesses. Some of these lines of business says, hey, I want to make sure that nobody can see my data. Or I want to make sure that if my developer does something in the cloud, that they don't disturb somebody else. Or more likely, somebody else doesn't disturb me. So we're going to handle different lines of businesses. So we had our retail line of business. They wanted their own set of accounts. Our analytics team, they wanted their own set of accounts. And then our shared services team, things like our DNS servers or NTPs or security stacks, things like that, they wanted their own set of accounts. Okay. So now we had 6 roles, and we spread them out to 11 accounts and 66 roles. So we had delineation by environment and then by lines of business. And then as this grew, obviously we had a lot of accounts being created, a lot of roles being created. So there was still lots of roles that were out there. But I want to say that the lots of roles really isn't the problem, because we're trying to make the segregation of duty a reality here. So if you want segregation of duty, you're going to want more roles. So really, what did we add here to our little checklist? We added that now roles are scoped into the account. So you as an engineer in one account have no access as an engineer in another account, because they're actually separate roles. So we accomplished that. Okay? But these roles are very generic, right? Now, I'm an engineer. If you asked people, hey, I need access into an account, what role should I get? Everybody said, I want to be an engineer, because that gives me the access that I need. But that might not be the right access that they need. So what is role rationalization? It's really redesigning roles based on risk and access needs. And we had 2 inputs into this to try to tease apart this engineering role. So we had segregation of duty in other areas, but this engineering role needed to be pulled apart a little bit. So we had a provisioning strategy. So this is from a high-level provisioning strategy. What do you want the roles to actually do? Let's go and ask people. And then we took a look at some of the prior usage. What are people actually doing with the roles? Just because you gave them access to IoT, did they do anything with IoT? I don't know. Amazon provides actually something called Access Advisor, which is a nice little service within the IAM service that can tell you based on a role what that role or what that user has done in Amazon. It's still a very high level. It tells you at the service level, not really at the action level. So you take that information, and output of that is going to be a list of candidate roles that we're going to go ahead and implement. Okay, so this is a process here. It's a 5-step process we took. So the first step here is to review the current roles and policies with the role owners. Really, let's just sit down with the role owner and talk to them. What do you want this person to do? Then we're going to go. And that was our top-down strategy. And then from the data, we collected and parsed our CloudTrail data and looked at some of their history to see what people actually did. And we also looked at our Access Advisor data to see what was in there. Then we took all that information, compared it to a list of job titles. We had database people, we had infrastructure people, network people, you name it. We have job titles for everything. So we took all that information, compared it to the list of job titles, and then refined those current roles and policies to better match those job titles. Then went ahead at the end to update all that information in our corporate LDAP, or the IDP. So from a high-level provisioning strategy, we wanted to make it easier when we went in and started talking and interviewing with some of these folks. And from a high level, we said, hey, there's a consumer, there's a creator, and there's a manager. The consumer would be like your developer. They would have the ability to launch resources, and really from a governance standpoint, their policies are very strict and mostly a read-only type of role. The curator role, on the other hand, would be your traditional engineer type of role. They would do automation release management. They can create artifacts, so CloudFormation templates, stacks, and whatnot. We can monitor them through alarms and dashboards. And then we had the manager role. These are people who are sort of project agnostic, in a sense. These are operations or information security roles, and they're there to manage the environments, and they are monitored and audited as well. So just take a sampling of current policies that we had. We took a look at how the policies tied back to the different job titles we had. This is just a sample of job titles. Create a little matrix here, and we pulled out some of the actions. And you can see that everybody had the ability to run instances. They all had the ability to list instance profiles. Nobody could create a user, because we didn't want anyone to create users in our account. We could list events in the EMR and then create database instances. And the one thing that was unusual is that our IAM engineer couldn't even create a user. Sometimes they need to create users. This became a problem. So the next step was, that was from the interview process. Then let's take a look at the past data. So we collected about 3 months of CloudTrail data, about how long we were out there in the cloud, and looked at all the users, basically pulled the user data out and saw what event they did. We tied it back to an action, one of the Amazon actions. We then mapped those actions back to the various job titles. So we took those users, a user here or Bob, and said, what is their actual HR job title? And then did a histogram. So we just collected all this data by job title, basically aggregated it, and looked at the total number of API calls per service per job title. Now, there's a lot of actions in Amazon. There's a lot of things you can do. I think at last count, there was almost 3,000. So it turned into basically a chart like this. We had 2,700 actions, about 50 job titles. You multiply that out real fast, over 100,000 different data points you have to go and analyze. All right, so let's take a look at just one little sample up here in the corner and see what that looks like, what it came out to be. So based on our past chart, took these same 6 job titles and counted up what they actually did. And then what we found was there were some similarities forming here. We could see, hey, look, the infrastructure engineer and the solution architect are basically doing the same job. And our cyber threat analyst and our internal threat analyst, they're also doing the same job. The database administrator, however, is doing something different. The IAM engineer is also doing something different. And the one thing we found was the IAM engineer was actually creating users. We found out they were doing that through the break glass process, which they needed to do. So we wanted to sort of stop that behavior as well. So we had all those 100 and some thousand data points. How did we map those out and come up with a good algorithm? So what we had to do was normalize the data. So we took all those data points for each job title and basically counted them up and made a percentage, just divided by the total of those actions. And then we just calculated the difference using this, I don't know, 1,000-year-old algorithm. It's basically taking n space data points and seeing how closely they map to each other. So we went through each action for, let's say, 2 job titles, one by one, took the differences of each of them, and then summed them up, and that gave us a number for these 2 job titles, how closely aligned they were. When we did all that, and then sorted it, we were able to visualize some data here. The blues are sort of job titles that are essentially doing the same, and when we color-coded on the red side, these were job titles that were doing things a little bit differently, a little bit more unique. And based on this, so this was really give us some good guidance. It was not a we didn't take this and just implement what this chart gave us. This was really a tool to help us narrow down where the roles really are. So we could see that there was a cluster of these roles up in the corner that really did the same job, and then some very unique roles down in the side that did very, very different things. So when we took a look at this data, and then we took a look at how the outcomes of the interview process when we talked and sat down to a lot of the role owners, we were able to basically tease apart this engineering role into some new candidate roles. So we created an IAM manager role and a threat analyst role. We created a solution engineer role as a creator, and then as a consumer role, a database user. So what did that really give us from a governance side? It really gave us the ability for a role owner, when they see a request that comes in from, let's say, Bob, we can ask Bob, what is your job title say? And then from that, we can tell what role they really should be in, as opposed to just the generic engineering role. Now, this is not a once and done process. This is going to go on and on and on, right? So this is a continuous process. So as the months go on, we're going to continue to refine the roles and come up with better roles that meet the needs, because the business is always changing. Okay. So now back to our checklist. Now we're at the point where we have a well-defined request process. Now the role owner isn't coming and asking me, hey, is Bob allowed to have this role or not? Now we can say, well, is Bob a database user? Yes. Give them the database user role. Okay. It makes that process go a lot smoother. And also now, the policies that are behind those roles were refined in such a way that it only gives them access to what they need. Basically, the less is more principle. So the roles now have the correct policies attached to them, and the roles now match the job titles. So kind of putting it all together, from a visibility standpoint, the request for access, that's all still very visible. The account usage is very visible from the CloudTrail data, and we have a very visible password policy. From a compliance standpoint, we know who's got access to what and to when, and the justification that went along with it. And we know that that was the right access that was granted. We also have the ability to look in the Access Advisor or in CloudTrail and see that, to make sure that, if there's any additional permissions that somebody has, then maybe that privilege should be adjusted, the policy should be adjusted. So really, in summary, what's the key takeaway here? Is we were able to achieve this really through the federation technique. You really want to be able to federate into your environment without individual IAM users. You want to leverage a workflow to grant authorizations. You want to use your account structure in your least privilege model. So your line of businesses, that's what worked for us. Something else may work for you. That really helped us isolate data as well as blast radius. And then the continuous process, continually reviewing your roles and your permissions. Okay. With that said, there's actually some more interesting sessions coming up around identity and access management. And also, if you wanted to know more about the Vanguard journey, there's 4 other sessions that my colleagues are hosting here at reInvent, which you can go ahead and attend. See some people taking some pictures here. Okay. With that, I want to say thank you. Thanks for listening to our story.